Oh my, look at the carnage. I did much more than that. I completely busted the mount that holds the other brush in place. Well, I didn't really have a use for this anyways. I was just curious to see whether or not it would work. And, well, in fact, it would work. Which makes me wonder why the hell these guys butchered this thing and left it on the side of the road. I just decided I want to take this belt off. And this is an interesting tensioning mechanism here. It's just a matter of rotating this bolt head a little bit. And this little torsion deal here loosens right up. Makes the belt come right off fairly easily. I'm going to see if I can take this all the way apart because I'm curious how that's put together. That's kind of a neat design. So it's just an eccentric gear or eccentric pulley, really. The center point is offset from the axis of rotation of the pulley. So what you do is you loosen this bolt up, you put a wrench on these flats right here and turn this to put tension on the belt, and then while holding that wrench you would tighten this down. Fairly simple design and yet effective. And we get a bearing right in there. Actually feels like a pretty decent bearing. Probably not worth the effort of getting it out of there though. Alright, so let's see, the motor is junk, courtesy of me. Although, look at the way this motor, this motor is, I don't need a direct induction motor. Can't think of any applications for it off the top of my head. They're good for blowers and vacuum cleaners and certain power tools. This flywheel has actually got holes in the back of it that are drilled to balance it. So they actually took the time to balance this flywheel, try and help with vibration, I assume. Connecting rod assembly right here. If I can actually get this off in one piece, it might be worth hanging on to, because I don't know if anybody actually ever orders one of these to repair their compressor or not, but they want like $47 for this. But I think it's just one of those situations where nobody ever orders it. I bet you nobody has it in stock even. I bet you it's one of those things that, everybody's like, can you imagine taking this compressor to a repair shop and the guy takes it apart and finds out it needs this connecting rod, and he says, yeah, it's $48 for the connecting rod and you owe me for some labor, so it's going to be like $120, $150 to fix it, whatever. Who would put $150 into fixing this compressor that I think for like $300 you can buy it brand new? No, it's not left-hand thread. I just put my 3/4 inch wrench on there. I put this pry bar in here to stop the wheel from being able to move, and bashed on the wrench with the dead blow mallet to break it free. Got myself a nice fine thread bolt out of the deal. Alright, it lets me take the belt off. What the heck? How do you get the piston to clear? How do you get this connecting rod to clear the flywheel here? I think I know the secret to that is probably going to be take the head off, and that allows you to pop this, what they call a cylinder or a sleeve, out of here, I think. Oh, look at that. The whole thing comes out. So there's almost like a little reed valve in here by the looks of it. So this kind of acts like a little two-stroke. So this connecting rod assembly is what they call this part, but it actually also doubles as the piston. Some rustification in there. Yeah, maybe nobody would want that. The condition it's in. Well, we got a little muffler here on the intake. That might be worth doing something with if I can get it off without breaking it. This whole casting here looks like it's an aluminum casting. So we'll separate the motor from this just because I can put it in my pile, my aluminum scrap. How the hell's that motor mounted to that thing? In other words, how's this motor mounted to this frame? Must be some screws down in there I can't see. These heads right here, which look too small to actually support it, actually are for long screws that go all the way through. They hold this rear bracket assembly that I busted up on, but they also go through this whole part right here, right into the frame. I'll tell you what, these fan blades that broke off right here, these broken off areas, they're razor sharp. So they get a bearing. The front shaft of the motor is supported by a bearing that's pressed into this housing. So I'm not going to be able to get this motor off of there unless I push either the bearing gets pushed out, or okay, the bearing will come out easy enough. But none of that's going to happen unless I get this pulley off of here. And well, guess what? Nothing to indicate what the hell. There's no set screw or anything holding this pulley on. So maybe that's just pressed on too. You know, one of the nice things about taking something apart that's all busted to hell that you're just scrapping is you can be pretty ruthless. It'd be a nice flywheel for a model engine. You can see it was cast. Like I said, because I'm not really looking to preserve much of this thing, I can be pretty rude with it. So I just bashed on it. It's aluminum casting, cracked pretty easily. And that makes this separate from this, so this I can now throw in my press a lot easier, I think. Maybe be able to actually push this out. Because this will go in my scrap motor pile to go to the scrap yard, and this piece of aluminum right here will get to go with the rest of the aluminum scrap. But I'd like to, you know, I take that to the scrap yard as it is right now, and automatically typically the guy's going to take one look at it, and if he catches that bearing and stuff in there, he's going to see that a lot of that's the weight to it, and he's going to degrade it. If I take that out, then it's just all aluminum. That's actually still a pretty good bearing. So these are Chinese bearings, cheapies. made by a company called Peer, P-E-E-R. I haven't heard that one before. But the part number on them is 6205, so that's pretty standard size, I think. So I'll put them in my used bearing drawer. All right, so last thing I want to do is just strip a couple of pieces off of the old pressure switch, and that's this automatic / manual pressure release valve. Just break off this one-shot hose clamp so I can get this hunk of hose off of here, because this is a barbed fitting underneath here, I think. So brass NPT to barbed fitting is definitely something that I would want to save, especially since it'll cost you probably $4 at the auto parts store. Alright, so just cut this a little bit so I can get that off of there, and yep, that's what it is. That's a good usable barbed fitting. Alright, so now I just temporarily laid my compressor in here just for a mock-up, and I can see that I got plenty of room to mount the compressor on this plate. That'll be a piece of cake. Just drill 4 holes and bolt it down. But I don't want to do that until I've kind of thought out how I want to handle connections and everything. So the first question is, what am I going to use to connect from the compressor to the tank? And what I want to use is this copper line because, well, quite frankly, I mean, although this, like, for instance, this scrap of airline that I took off of here, this is, old, but if I went and got a scrap of airline like this, it would be a lot easier to make my connections, definitely. But I'd worry over time how this would hold up, because this says on it that, for instance, this piece right here, it says do not use pressures greater than 300 psi. Okay, well, we know that according to the manufacturer, the tank's max pressure is 200 psi, so we're not even going to get close to 300. Question is, 300 psi is what this thing's rated for when it's new. This is going to be outside a lot, sitting out there in the weather. What's going to happen over time as this degrades? What's going to happen to that rating? And I don't want to be anywhere around if that thing were to blow. So I'm going to go with the copper line. What I'm going to do is I'm going to attempt to rebend this line and reuse it. So then I got to think about how my connections are going to go. Well, my first thought was maybe I'll use this check valve because I don't have a bushing in brass that will thread into the tank and reduce this down so that I can use this check valve. But I still need to use this check valve because I need a port for the well, I was just talking about it last night when I was down here. The unloader valve, okay? So that little line that goes over to the unloader on the pressure switch. So I'm noticing that this port is actually just wide open to this side right here, which is what threads into the line going to the compressor. So this threaded onto the nipple on the tank, and this threaded on, this actually is for this nut right here. It's a flange fitting right there, okay? So, my point is, if I had to, I could probably put a T in here and have the unloader line come off of the T if I had to. That would be if I wanted to use this check valve. So in other words, come out of here. This fitting right here, I already checked. This fitting right here, no, I'm sorry, this fitting right here, which threaded onto a nipple coming out of the tank, is good old NPT pipe thread, okay? Pipe thread, meaning it has a taper to it. This will not thread onto here, which would have made my life a lot easier. If I could have just threaded this onto here, I could have then bent the line over to here and had the unloader line come over and boom, Bob's your uncle. Well, the reason why this won't thread onto here, even though it seems like it's such a close fit, well, that's because this is not pipe thread. This is not tapered. It's probably dimensionally the same size, but this should have had a nut like this on it, going to it probably, and the pipe went down inside there, and this clamped down and tightened that in and pushed a little brass ferrule down in there to a Will Ferrell to make that actually tighten up. So if I want to use this, it's going to get kind of involved real quick in something weird. The other thing I could do is I could actually turn this whole compressor around, because the line comes out of the compressor on this side. And so I could actually have this port right here coming out right like where this is here. And then I'd have a lot more copper line. Or I could even just get a hunk of copper tubing and custom bend it. But I'd like to use what I've got. So let me shut the camera off and rethink this. All right, so I'm definitely not going to use this existing check valve on here, because it's, like I said, it's going to give me a problem without having a place for the unloader line. You know, I actually thought about it afterwards. I said, geez, I could actually probably drill this and tap it up here, maybe on the end. But anyways, look at that, how rusted that is. That's just a piece of junk. And then this end that's been open to the open air for who knows how long, that's got a mud dauber's nest or something going on down in there. It's chock full of crud. So that's garbage. That's going to go away. I took that out because I wanted to see what size this thread was, and I'm happy to say that it's standard 3/4 inch NPT tapered pipe thread. I had this 3/4 inch elbow. Interesting thing about this, if you're not used to pipe thread's kind of funky. There's a chart you can find easily online. Just Google NPT pipe thread sizes, and it informs you that, for instance, this, if I measure over the threads, it's almost spot on 50 thousandths over 1 inch. So, you know, logically you might think, well, that would mean that's a 1 inch fitting. Nope, that's the 50 thousandths over 1 inch over the threads is the standard size for NPT 3/4 inch fittings. So what I need now is I need a 3/4 inch reduction bushing. So I'm going to have to go buy one because I don't have one. And then what I'm going to do is I'm going to put a nipple in like this, and then put this on, bend this line over to get it to go onto here, and then run my unloader line over to the new switch. Which, you know what? I haven't looked at the new switch since it came in, and I just assumed that it would have an unloader line port on it. And I hope, yeah, there it is right there. Okay, there's your unloader line to your unloader valve. All right. So I am happy to see that that's there. This has that, that burnt electrical smell, which must be a product of just this type of plastic that they use on these things. I don't know. So that, let's see. Oh, of course not. Why would that thread on there? That would make perfect sense, right? Are you kidding me? Oh yeah, okay, it is. It just them funky Chinese. All right. So that'll work, but you can. Well, it looks like I'll have to take that into account there. I want to be able to reach this switch, which is. Oh, cripes. Well, actually, I'm pulling up on it intuitively because it's a knob that looks like you should pull on it, but I guess I should. Nope, that is what you're supposed to do. Oh, cripes, that's a... Man, that's hard to pull.